I'm going to give you some selected help with tracing functions worksheet number 2. Let's check out exercise number 3, compute area parallelogram. Here's a call statement, a function call, and we match that function name up with the function named compute area parallelogram right here. We have two parameters in the parentheses, and here we have two parameters. Ignore the word by val. We don't really need to know about as integer at the moment. So you can see that the names of the parameters are b and h, and the 5 plugs in for the b, and because 8 is listed second, it plugs in for h. Now we have to execute this function. So b is really the number 5, and h is really an 8, plugs in there for h. So let's record that. Now this function is pretty easy to trace. B times h is really 5 times 8, which is 40. And because the return executes after we multiply there, as if that were in parentheses, we always do the multiplication or the addition or the subtraction first, and then the final answer, 40, gets returned. It gets returned back to where the function call was, and all of this is now really the number 40. And that 40 gets placed into label 3, so the answer to number 3 is 40. Moving on, let's take a look at this next few lines of code here. We have a bunch of variables being declared. Num cookies is 3. These other variables are 0. And we hit this line of code, which tells us to pass two parameters. Be careful here, because we're now executing the function compute cost, which is right here. Ignoring by val, ignoring as integer, but noticing that there is a comma here. We have two parameters, num items and cost per item. Num items matches up with num cookies, and that's just the way it works. Visual Basic knows that whatever number is currently stored in num cookies, the 3, it flies down here, it gets passed as a parameter, and it lands into this parameter num items. So num cookies up here is equivalent to num items down here. Let's reflect that on our scratch paper and do the same thing with price per cookie, which flies down here and plugs into the parameter cost per item. What is price per cookie? I don't see it mentioned anywhere in this area of the code. If I scroll up, I do notice that price per cookie is a constant typed out in all uppercase letters, and constants should always be declared at the top of a form. They are constants. They're accessible anywhere in your code window, so they should be placed up here, and price per cookie is 0.5. So there's a 0.5 stored here, and that 0.5 gets passed it down the code window, and 0.5 lands right in here for this parameter. So let's reflect that value by putting it here in our scratch paper. Okay, there's not much to do over in the body of the function. We treat this as if it's in a set of parentheses. Num items, which is 3, is multiplied with 0.5, and that works out to be the number 1.5, which is then returned back up to where the function was called. Right here. All of this is replaced with the number 1.5. We're not quite done yet, because that 1.5 is being assigned into the variable total with tax, which was just declared, and we now overwrite that 0.0 with this new number 1.5. The next line of code takes the variable total with tax, without tax, 1.5, and plugs that 1.5 into the label 4. Yes, we could have written this code differently, but it does prove a point that the compute cost method is reusable, and even if this code up here were written to work with num candy or num granola bars, it would still work. It's not a cookie-specific function. This compute cost function can be made to work with any item and any price for any item. Okay, you can do number 4 by passing these two. Oh, we already did number 4. I'm sorry. You can do number 5. Whatever values are stored in those two parameters get passed down to compute tax. Compute tax returns something. It's very similar to compute cost. Now let's just talk about vocabulary. Vocabulary here in number 6. One of the important words that I'm emphasizing here is the word parameter. And another word that you should learn now is function header. A function header is the first line of a function. And in the function header is always found the name of the function as well as the set of parentheses. Once in a while the parentheses will be empty, but usually the function accepts parameters, and the names of the parameters are always found in the set of parentheses on the function header. So in the case of compute circumference, up here you figure out what the name of the parameter is on this line of code here. But I'll tell you that for compute area parallelogram, the names of the parameters are b and h. Not base and height, even though that's what they probably represent. B and h are the names of those two parameters. Anyway, number 6, you can answer that, and for compute circumference. Number 7, well, let's talk about the number of parameters. In this header, there's one parameter in the parentheses, because we always ignore by val and as integer. Those are not parameter names. So this function accepts one parameter. You figure out the answer for number 7 in regard to compute area parallelogram. How many parameters does it have? And number 8, return type. That's an important vocabulary word to know. The return type of a function is whatever data type you find spelled out at the end of the function's header. So these words, these phrases here, end with a data type, either double or integer. So these are called the return types for these functions. Compute cost returns a double, which is really the same thing as a decimal number, because often when you go to Walmart or the store, your cost is something like 197. It's always some number of cents. I know it's annoying, but you have to reach down for some pennies. It would make no sense to have a function called compute cost and have as integer typed out, because that's telling Visual Basic that this cost will always be a whole number, and therefore a whole number will always be returned by the function compute cost. Well, that's just plain wrong. It's usually going to be a decimal number, so that's the way business works. But in the other case, in the case of a parallelogram, where you're being provided a base and a height that are whole numbers, and if you know that the area is always going to be base times height, if you have a whole number times a whole number, your answer is always going to be a whole number. Isn't that a true mathematical fact? So for that function, it's more appropriate to have as integer here. Since these two parameters are integers, the final result's always going to be an integer when you multiply. Unlike compute cost, where your answer is probably going to be a decimal number because the cost per item was a decimal number, and decimal numbers multiply together to make decimal numbers. Hopefully that will help you with the answer to number 9.